Ladies and gentlemen, welcome to today's webinar, the last day of our digital week. Yesterday's webinar, we learned how important translators between managers and data scientists are. And today we will learn how you can overcome some of the most common misunderstandings between these two groups. We will also get a very practical insight into how machine learning actually works. My name is Friederike Rieder and I'm very happy to have two great experts with me. These are Professor Johannes Binswanger, he will provide the managerial perspective, and Marc Schöni, who will give us very practical insights about AI and machine learning. I would like to welcome Marc and Johannes. Thanks for taking the time. Marc, should we go into your garage?
Yes, let's do that.
Hi, Marc.
Let's go there.
Takes a long time we haven't talked.
That's right, Johannes. That's because I'm your chief data scientist. I don't get to see you that often.
Oh, but Marc, data is very important to us now. Data, Marc, is really the new oil.
I'm glad you say that, and I'm sure you read it somewhere in one of the 10,000 articles that say that. You know, because really the way I think of it, Johannes, is data is more like seeds, and we need to think carefully about the seeds that we want to plant. Seeds, like in agriculture, exactly. And we need to think carefully about the seeds we want to plant and what we want to harvest from that. So it doesn't just happen automatically. It's something we need to do.
So data is the new seeds, Marc.
Yes.
And we at Rosenberg Bank, we believe 100% in the potential of data, and we want to get powered by AI. So data is at the beginning of this process, and actually, Marc, why do we actually need data for?
That's a good question. Well, we need data because what we want to do ultimately is train a system that can find some sort of pattern in the data and use that to make predictions. So without data, there's literally nothing to learn from.
So it learns from the data.
Exactly.
So we are using this data, our data from our data warehouse, to automate our credit decisions. So we have no caseworkers anymore. It's AI deciding who gets a credit from Rosenberg Bank or not. So Marc, you always want me to know how this stuff works.
True.
Well, okay, so today I'm coming with you into the garage. And so show me.
All right.
Let's go to the garage.
I'm very excited you took the time to do that. So I want to show you a little bit about how we come to this point where some smart system can make a decision about the loans. You know, and let me first start off by showing you the data that we're going to deal with. I'm showing it in your favorite tool.
This is data. This is our data from Rosenberg Bank.
Yes, exactly. And
it's coming from our data warehouse.
Almost. It's actually, if you didn't kill the data warehouse project 2 years ago, it would have come from our data warehouse. But now what we have to do is we collect
still
the
beautiful.
data.
It's still beautiful data.
Yes, at first sight, very beautiful. But what do you think about things like these, Johannes? When somebody says they have a current loan amount of $99 million, do you think that's actual
Maybe
number?
They have a lot of money at our bank.
Well, maybe we're looking at some sort of data quality issue here. And that's actually what's happening. Okay. And we got many more of these issues. So if you look a little more carefully into the spreadsheet, you see there's missing values here when we talk about credit scores. You see that?
So there's nothing in that cell.
Yeah. It means we don't have the information that we actually would have liked to have. And also you may notice that we have different scales for this credit score here. So in some cases, the numbers go up to 700.
So the credit score, Marc, the credit score is always between 600 and 700.
That's right. And then we have some values that say 6,670.
That makes no sense.
It makes no sense. And it just shows you that the data that we need and that we deal with is actually a bit messy to start with, and it needs quite a lot of attention of our team.
So that data is not as beautiful as I want it to be.
Not yet, yeah. And that's why you shouldn't have killed the data warehouse project.
Marc, can we still work with that data?
Fortunately, we can, yes.
Yeah.
And I want to show you a little bit of how we approach that.
What about other banks? Do they have better data than we have?
Well, I can tell you we have, at the previous bank I worked, we had the same problems. It was the same even outside of the banking industry.
What about other banks or other companies outside the banking sector?
Everybody has their data quality issues, but it's important to understand that they need attention, but then we can still get value.
I feel somewhat better. Okay.
I bet you do.
But Mark, we can still do something with that data.
Definitely. Okay. Now I'm going to show you what.
Show me.
So I'm taking you to my data science workbench here. Okay.
This is your workbench. So it looks like an empty canvas.
Almost.
But you have something it reads loan defaults.
Exactly. That's the data set we were looking at, right?
That's the data we just saw.
Exactly, but it's a cleansed version of it. So the team and I put a lot of effort into preparing the data to make it suitable for machine learning purposes. Okay.
How much time did it take you to clean this data?
Well, how much time do you think it would take?
Well, when I think about the percentage of the time, maybe 30%,
yeah,
40%.
I was thinking that's along the lines you were thinking, but actually in reality, we take about 80% of the time for data preparation. So that's quite a lot.
80%.
Yes.
80%. Okay.
So that 80% already went into that, right?
Yeah.
So what we're going to do now is basically I'm going to show you how we can build a machine learning experiment. All right.
Mm-hmm. Based on our beautiful, actually not so beautiful data from Rosenberg Bank.
But we made it as beautiful as it was possible. So here we are going to introduce a module that splits the data into two pieces. And I'm specifying here that I would like to use 80% of that data for what we call training purposes. And the remaining 20% I would like to save or spare for validation purposes.
Validation of what?
Well, what we're going to do is use 80% of the model, pretend that's all the data we have, hope it will pick up a pattern, and then the remaining 20% of data we're going to test the model with to see whether it learns something.
So you always talk about patterns.
Yes.
So AI is really about patterns recognition.
Well, to a large degree, yes.
So let me try whether I can make sense of this for the bank. So we have two types of customers, clients. One type, they actually pay back their loan, and the others, they don't. And then they have other characteristics, like they have an income, they live somewhere, they have a credit score, and so on. And so you are saying there are certain patterns that are associated with someone paying back a loan, and then there are other patterns with the group of people that won't pay back the loan.
Exactly, you got it right.
And so if you split this data, we kind of we let an algorithm go to pick out these patterns, and then we won't use it immediately for real cases because this would have been, we at Rosenberg Bank, we always test before we put things into the market. So we use the remaining 20%, we put 20%, right, of the data. We pretend these are new customers, and we check the performance of our AI solution, how it performs on these cases that look new to our algorithm.
That's exactly what you got it right.
I see.
So let's take one step further here. Next step is we want to train that model we talked about, right?
What does training mean, Mark?
So in this case, I'm giving it that 80% of the data. I'm also telling it what is the target we are interested in. And in our case, the field in that, you can think of it as a big spreadsheet. That column in that spreadsheet is called loan status, and it has exactly the information in it you said before. Did the customer pay back their loan, yes or no?
So this information about whether our customer paid back, it's just a column in a spreadsheet.
In this case, yes. And what we're going to do is we hope that there's enough of a signal that the algorithm can pick up to identify the underlying pattern of will the customer pay back their loan or not.
That sounds reasonable enough.
So we're going to do that and start using what is called a logistic regression algorithm to see
so that's an algorithm now.
Yes, now we're really at the algorithm.
I get to see an algorithm.
Who would have thought, right? Well,
I always thought this was very complicated, but it's just a drag and drop module here.
Yeah, in this case, that's true, but still there's a lot of work that goes into it. So don't be fooled by that.
People that build this. insights.
Yes, definitely. And also, as we talked about, the amount of time it takes to get here.
Right.
So here, basically what we're doing is we're using the 80% of data that we have to train the model. That's what's happening in that trained model.
So once again, training model means we have all these patterns that we just talked about, and training means the algorithm is now trying to catch these patterns and kind of distill them into a formula, right?
Exactly. And with the idea to then use that formula to predict whether a new customer will actually pay back their loan or not, right?
I see.
And because, as you said, because at the Rosenberg Bank, we take pride in testing our applications. We use it first year with some testing data, the 20% of data that we put away.
Yeah.
Right?
We present these are new customers,
exactly.
Although we already know whether they paid back or not.
That's exactly
and
right.
So we are using this as fake new cases. It's actually just test cases.
Exactly. Because here you see the loan default column that says that loan wasn't paid back. That one was. And now what we get is the prediction of the model over here that we'll see, here default, no default.
So this is produced by the algorithm.
That's the output of the trained model, exactly. And you also see some missing values where something didn't go as planned.
Because we have no inputs.
Exactly, because we were missing input. And that goes back to the data quality discussion.
So that column that we just saw with the scored probabilities or the decision that the algorithm made, 100% data-driven.
Yes.
That's what we need in that system that decides whether one of our online applicants for the credit actually gets the credit or doesn't.
Exactly.
Yeah.
And then let's go to the last module here where we sort of perform an evaluation of the model. And it will give us a couple of metrics that you can see down here. And these metrics basically let me and the team make a judgment on how well that model works.
I read accuracy, precision, recall, it's very small. Yeah, it's no household names. Actually, I hear this for the first time.
Well, it's for you from the business side. You don't have to understand the very details, but you have to be familiar with that we measure model performance in different ways, and there's different types of errors.
What's model performance, Mark?
Well, model performance just tells me whether the model we trained actually learned the pattern or whether there was a pattern at all or not.
Yeah. And so what number should I pick?
Well, here, an easy one to understand is accuracy, which just tells us in
0.77 is good.
0.77, you can read that as 77%. And basically, it just means 77% of the predictions were right.
What's reasonable?
That's reasonable, but we still have a problem, Johannes. And the problem here is, when I look at that recall metric, it's relatively low, and it's at 35%. Well, recall tells us, out of the cases that actually didn't pay back the loan, what percentage of these cases did the model get? So basically, out of all the cases where the money didn't come back to Rosenberg Bank, the model is only capable of detecting 35% of that.
Not really sure what you mean, but it doesn't sound too good.
Yes, it's definitely nowhere near as good as it should be.
But then we have a high number. You want to show me something?
Yes, what I want to show you is that I can now basically go and try to find another algorithm and see whether that other algorithm maybe gets
better numbers. And so these are the KPIs of the algorithm?
Yes, you can think of it that way, exactly. So what I'm doing is I'm cloning that training experiment, as you can see, and then I'll be pulling in a new algorithm. And in this case, I'm going to use a boosted decision tree. It's a different kind of algorithm. Yeah, yet another one.
Sounds fancy.
It is fancy, and it's very powerful for specific problems like the one we have here. And then I let the computer do its magic again.
Yeah.
And it will probably take, about a minute or so to calculate.
Well, Mark, honestly, these things are too complicated for me.
You think so?
You are the experts. You decide what number is good for us. You know Rosenberg Bank, so you decide.
Well, I tend to disagree a little bit with you there, Johannes, because to some extent you also, as the business manager, as the person that knows banking much better than I and my team do, you also have to be aware of
why do I need to know something about banking here?
Well, because you are able to tell me which type of error is worse here. Is it worse that the model makes a prediction of somebody not paying back and they do pay back? Or is the opposite worse? That is different implications of the business.
So if we reject the customer because they don't pay back, we think they don't pay back, but actually they would have paid back, then, well, we lose a client. And we would have earned interest with that client, right? And if we don't reject the client that actually doesn't pay back, then we lose all the money, right?
Exactly. We write off
a priori, the second case looks more problematic to me.
I would tend to agree with you on that, but it shows you that it's a judgment that needs to be made.
Well, if we don't lend anymore because we think there's a risk for everyone not paying back, then we can close as Rosenberg Bank. Sure, yeah.
I agree.
Even I understand that, Mark.
There you go.
But so which number would you pick?
So in this case, taking the information you gave me about what is worse in terms of error, I would tend to...
I just gave you some information?
You did. You said it's worse for you that we basically write off a loan because the model missed that.
Yeah.
Right? And in that case, I would focus on recall, because recall measures how much of the cases that went bankrupt, so to speak, the model get. And what you can see now, this second algorithm we used is better at doing that. It's still nowhere near very good.
So we had 0.37 before.
Precisely. So this is now 51%.
Yeah.
It's a significant change, but still probably not good enough to then just take it into a productive environment and expose it to our clients online.
So, Mark, I still find this pretty complicated. Not sure I got it. I need some image to think about those things. But let me try to develop some. So let me think of our clients as fish in a pond. So it's all our potential clients. But the problem is some of that fish actually stinks. It's the rotten fish that doesn't pay back the loans. Yeah. That's stinking fish. Now what I want the algorithm to do is to catch all that rotten fish out of the pond. But then you tell me there's a problem. So what I want is I want to catch all of the rotten fish, but I want to catch, Mark, only the rotten fish.
Exactly.
Because I could catch all the rotten fish and there is a lot of healthy fish in my net.
Yeah.
So if I got your measures correct, then recall means a high recall means I get out most of the rotten fish of the pond, right?
Exactly.
But that doesn't necessarily mean that all the fish I catch is mostly rotten.
Yes.
If I caught all fish of the ponds, then I would have gotten all the rotten fish, but also all the healthy fish.
Exactly.
And so that's the trade-off between this precision and recall.
It's a measure of which error are you willing to accept, right?
So we would go for recall because we mostly care about getting the rotten fish out. At the same time, we don't want too many healthy fish. So that's why we also look at precision.
Yeah, you got that right.
So in other business problems, do we have similar measures?
Yes, well, we call this in the genre a classification problem, and that's how we measure the performance of a classification model. And there's other use cases for classification. For example, we can make a prediction whether a customer of ours will actually cancel all their accounts and go south of St. Gallen and go with the other bank. Exactly. Yeah. So that's customer churn. In the industry, we could use a classification model to detect whether our ATMs, the cash dispensers, whether they will break or not, for example. It's these kind of problems.
Whether machines are going to break down or not.
Yes.
So I have heard about that. So, and it's always, so you can use this precision recall and all that stuff. You can actually use it. It's generic.
Yeah, to some extent, yes. There's different families of problem, though. When we want to maybe find out how much money are our customers going to invest with Rosenberg Bank, we treat that as a different kind of problem. We call that a regression problem.
Yeah.
So there we have different error measures, of course.
So we have different measures, but it has similar interpretations.
Yeah, definitely. And again, there you need to have some sort of basic understanding of which errors are costly and how much so.
And you data scientists, you think that you need our input for making a decision about how good is good enough, measured by the amount of those KPIs.
Definitely. Mm-hmm. My team and the banking specialists in Rosenberg Bank, we really need to cooperate closely on this.
I guess we need to sit together.
Yes, I think we have to come to our garage more often.
But Mark, actually, this went very fast. So it just took us, well, I think it took us 12 minutes to develop this model. Mm-hmm. I mean, let's automate everything at Rosenberg. This is so cool.
It's not always
let's
that easy.
Automate this. Let's put this into production. I mean, the recall was pretty good.
Hang on. I mean, it's okay, but I would not have a very good feeling about putting this into production yet, right? Because we still miss 49% of the cases. So
49%?
Yeah, basically the 51% we get, and then the 49 that we sort of miss, right? So I'm not yet happy to sign off on this. I think the team and I need to put more time into this.
You think you'll get there? You always need more time.
Yeah.
But there is pressure on the market, Mark.
Well, I give you that, yeah. But I also want you to understand that when we talk about taking this into production, there's other things that need to, be considered.
But beyond the garage.
Beyond the garage, and also non-technical issues like how do we now take this prediction of the model, as you said, that formula that it was learned, how do we take that and put it in the hands of our employees? In which application does it need to go? In which business processes does it have to go? These are the things that we need to carefully evaluate as well.
So which employees do need this prediction? That I think it was in the score model thing that we calculated a probability that a customer is going to pay back. So where in our systems do we need that?
Well, you can think of the system that our bank clerks use when they're interacting with customers, that such a prediction could go into that user interface, into that application, and tell our bank clerk, this is the likelihood of that customer paying back or not.
And you wanted to hear that we need IT to actually make sure that at the right point, at the right time, this information is available.
Absolutely. There we need to come together as a team and basically draft that very carefully.
So that's one of the main challenges?
I would agree. Yes, definitely. And it's really, as I said, it's also, the challenge goes beyond the machine learning part. It's also then, how do we get our people to, let's say, for the lack of a better word, believe in this kind of predictions and really trust the output that a machine learning model generates.
So you're talking about trust? You are the data guy. You trust it. But how would you foster the trust of the rest of us?
Well, I think, to some extent, it also goes into a cultural discussion, the openness.
It's funny that you were talking about culture. You're always the objective data guy.
Yeah, that's true. But culture is big on your agenda, I know, right?
Yeah, it rings a bell. So what about culture?
So it's about, embracing new technologies, new trends, and being open towards them, and not just isolating oneself and saying, well, I don't believe in what's happening here, but really take a step back and have belief in certain things and have a growth mindset.
So how can I foster those beliefs? I mean, we believe 100% in data. So isn't that good enough?
Well, it starts with you, it starts with senior management, but it then has to trickle down through the organization.
You mean when it comes to the details of a caseworker who previously made the credit decision may actually say, I know it better than the system, and may override the system.
Exactly.
So we should not allow that someone of Rosenberg Bank overrides the decision of our beautiful algorithm.
You have to really think about how we approach that. There may be cases where it makes sense, but
that a human steps in.
Yes, exactly. But in general, embrace these kind of things, and that's the cultural aspect.
You mean we need to sit together and think about how we foster that culture?
We definitely have to do that. Definitely, yeah. And then what's also an important challenge here, Johannes, is that I get it many times. I heard it from some of your senior management colleagues that when we are done with this project, that this is the end of it, where in reality what we have to do is we have to actually carefully monitor how well the model works in production.
When we really let to make it real time, real case decisions.
Yes.
And so how can we monitor that?
Well, we have to put in place some, let's say, mechanisms, right, that basically track what the prediction of the model was for a new client, whether the model said the loan will be paid back or not, and then really take the time to observe whether it was paid back or not, and then see in how many cases the model was right or not.
But if we have a high recall, then we can be pretty confident, Mark, that we have solved the problem for a while.
We should, but again, the recall only relates to the data we have today, and maybe over 1 or 2 or a longer years period, that can change. The patterns in the data change, they're not static. So we really have to carefully monitor that.
So you think when our competitors change their behavior, or maybe our clients change the behavior?
For example,
I see.
Yes, we change our products and everything is moving.
Okay, so models get worse over time.
Definitely. And it needs
monitoring.
Yes, it needs monitoring.
That's interesting. Mark, I have your team working together with IT. But you have seen many other companies. Do you think that's the right solution?
That's a good question. And I think we're only 5 guys right now, right? And the question then is, where should we be put organizationally? And since we're such a small group, and I think it's safe to say that the topic of AI and data science in Rosenberg Bank is still only starting to evolve, I think you put us in the right place when you made the decision to put us in the IT organization.
We are going to grow.
Yes, that's our ambition.
So in 2 years, we have 15 people, 20 people. How would you arrange that thing in our organization? Where would you put data science?
Well, in that case, I think it will start to make sense to consider taking some of the people away from the IT organization and putting them in the business division. That will bring them closer to the real core experts. Exactly.
To the actual problems. I'll think about that. Yeah. By the way, Mark, should we have a chief digital officer at Rosenberg Bank?
Interesting question. I think that role has some value because it can bring together the IT world and the business-centric world. So taking an overarching approach of problems that arise in the digital age, but knowing IT well enough and the business well enough.
You mean it would help us to really cut through silos?
To some extent, that's
and
exactly
check
right.
that every division participates at the development of an AI culture.
Yes. And not only AI, but really new trends, in the digital age in very general.
So it would also bring IT and data scientists together. That's very interesting, Mark. Thanks so much for going through the garage.
Well,
you're a good guy.
Well, I like to hear that.
A good team. So for me, it was very interesting to have this idea that data are like seeds, because I see data can be very messy. Actually, I didn't find this 99999 very pleasant. And actually, honestly, I have seen this the first time. I was pretty shocked that you told me it takes 80%. 80%, that's what you told me,
that's it.
Of the time to clean that data. Then actually it went very fast actually to develop the algorithm.
In this case,
but then the challenge is we needed some really complicated numbers for evaluating them. And you, the data scientists, think that somehow you need our input. I think we need to sit together and do a workshop about those metrics so we can understand them better.
Would help, definitely.
And then I think it was really important for me to see that once an algorithm is developed and actually has a good performance, that goes very quickly after we have clean data. There is still lots of obstacles from really making this a successful project because we need to have IT to have the output of the algorithm at the right place, at the right time. We need a culture that is open to actually not questioning what the algorithm suggests. And overall, we can say, yes, maybe you're right. Data is the new seeds.
I like to think of it.
Beautiful. Let's make Rosenberg Bank great again. It's the best bank on the top of Rosenberg Hill.
Great.
Oh, thank you both. This was very interesting for me, and thanks for trying this slightly different format. So we have a few, the first questions from our audience. Thanks for those. Send us more. I'll take it from the top. What is the applicability of data mining in machine learning?
Well, I actually started in this field 9-10 years ago, when most people still called it data mining. So it closely relates in terms of terminology, I think. If I remember correctly, data mining was more associated with doing these kind of things within the database, whereas machine learning doesn't have that focus on databases anymore. It's a more general approach that it can happen inside of databases or in some definitely totally different computer environment.
You can even spill over to data lakes, if I may drop that.
Thanks. And which training material needs to be fed into the training model?
Well, it needs to be representative of what we are trying to find, the underlying pattern. I think it's a very good question, because there's instances in which it's really hard to get to that data. Maybe in the banking case that we used, it was fairly easy to do. But if you put yourself in a position of, let's say you're a machine manufacturer and you gather data of your machines and you're interested in predicting whether a machine is going to break, maybe you have to wait 10 years before ever seeing the machine break. So if that's what you're interested in observing, you really have to have that data.
And then you'll have new products already.
Yeah.
Right. So it's really not that magic that it can actually generate data about broken machines independent of whether a machine actually breaks. We need actually really breaking machines for learning the patterns in the data. We learn it from actual data.
What profile is actually needed to build these kinds of applications, Marc?
Well, I think most of the work is done by the role that I played, right? A data scientist.
What's your background? What's your education?
Well, I originally studied business informatics a long time ago, and I always was interested by data and data analysis, so I started doing statistical data analysis about 10 years ago, as I said. And I think the most important asset for a person that wants to, embark on a journey in this direction is to just have a knack for data, like the interest to find, stuff in data, be curious about these kind of things. And that's, to me, that's the most important asset to have. And then you can take one of these many courses that are offered online that you offer at University of St. Gallen. The training options are very manifold.
Thank you. How can machines actually learn to understand human behavior? People normally think and act not as machines, and it's not always in a logical way.
It only works if you have data about human behavior. But everyone has the smartphone or the iPhone all the time in their pockets. Or think about orders at Amazon. Amazon knows really a lot about us because it knows about our hobbies, about what we order, about what we are interested in to read. And so it's no surprise that Amazon sometimes seem to know us better than we do, because they make suggestions and we thought, oh, I should have figured out that I want to read this or order this. It's that we really leave a lot of data traces that makes us predictable, much more so than we actually would hope.
Well, today, what computers can do, Frederick, is they can look at a picture, for example, and let's say on this picture there's a person, and it can say, this person looks happy because he or she is smiling. But it doesn't have any way to figure out if that smile is genuine or not, whether it was a fake smile or not. So that's still far out from where we are today.
And we obviously need digital traces of behavior, right? Still with human psychology, what is the value of data science also in human resources?
Interesting question.
There are quite many applications for that.
Yeah, I think we talked about, in the play about the ability to predict churn of customers. And I work with customers that do similar projects when they're trying to predict which employees are actually more likely to leave us as a company. So that's very much a human resources problem. You could apply machine learning and data science to some extent in terms of identifying the best candidates for new roles, and there's a lot of applications, I think.
There are also a lot of pitfalls. So it's used for recruiting also, but then we quickly get into ethical questions. For example, let's say an AI application listens about how confident the candidate is or about the body language. Maybe the body language tells something about psychological problems or instability. And of course, we can train those systems similarly than we could train it for bank loans. But do we really feel comfortable as society with those solutions? So it's quite questionable. But it works to some degree, so there have been experiments with that.
I think the ethical aspects you point out correctly, so they're very important in all projects that happen in this field.
Can be very discriminating. Also monitoring the performance of workers. How fast is someone typing? You can measure everything. You can put cameras on their faces to see how focused they are. But do we want this?
Wouldn't feel too nice.
We have a lot to discuss as a society.
Here's a bit of a long question. I'm just going to read it. You mentioned that people should not deviate from the prediction of the model. Garry Kasparov, after he was beat by Deep Blue, held chess tournaments where machines and humans worked together. What was found is that a decent algorithmic advice and a good process for deciding who makes that decision, the human or the machine, as well as objectively better players using better machines but having a bad process. Do you have any experience with developing processes to determine whether the model or the machine should make the decision? So when to actually apply machine learning?
Well, the problem is first with humans is that humans can be biased. Let's face it, in the past, more often men got a job, a high management job than women, or probably the same with banks, men more often got the credit, or skin color plays a role. And initially, when we try to automate a decision based on the data we have, the algorithm just learns all the prejudices that we put into the system that are in the data. Now, what's the potential with the data-based algorithmic solution? It's that we can actually now see that it's discriminating. And so we can tweak the algorithm such that it becomes less discriminating. And that's a real ethical positive benefit of AI solutions. So you can make it less biased, but it's not automatic.
You have to actively work on it.
Thank you. I accidentally dismissed a question. I'm just going to pull it up again. It's actually a comment. I'm not sure whether companies need a CDO to break down the business silos, since so far the CIO was in charge of doing that. Do you have further comment on that, Marc?
Well, I would tend to agree to that statement, but it really depends. It's really different from one company to another. I've seen, unfortunately, companies where the CIO did not manage to do that. It's not the person's fault per se. It's more of a cultural thing where IT just thinks of itself as the service provider of IT services, and that's it. And I have seen the total opposite of IT organizations that are very open, that actively work with the business, propose new solutions and stuff. So it's really depending, I would say, on how does your company operate today.
It's a trade-off. You also generate visibility and you signal that this is very important to foster AI. At the same time, you have more people talking about what we should do, and it doesn't always help to improve decisions.
Thank you. One last question, except more come in. What kind of technology is trending now in the AI field? Is Python and or R the right starting point for beginners in your view? Or where should beginners start?
Well, I think personally, if you're a beginner also in terms of programming languages, that the language of R is easier to learn. If you have never had any exposure to programming, R is easier to learn. When we look at sort of the emerging algorithms and stuff, many times we see that these are first implemented in Python, and in reality what ends up happening is most people that do data science actually use both Python and R to a large extent and pick the tool they need for the task that's there.
I think R is great for data cleaning. Actually, what we talked about, it takes 80% of the time. I tend to prefer R for that. And then it really depends. So with Python, it's easier to embed it in other IT applications. R is more in the spirit of data scientists and statisticians. So if you really want to embed it immediately after the project is finished, Python is probably preferable. Also for neural networks, Python is stronger, whereas for other methods, it plays no role, or even R is strong.
Thank you both. I think our
Thank you for
time's up.
joining.
Do you have any closing remarks?
Well, I think that it's important that even top management has some idea about what AI is about, that it's no magic, that it's really all based on data, that an algorithm is not good per se, but we need to measure how to evaluate an algorithm. And I think if you have a basic understanding of all these points, you can make better decisions, better management decisions. And I think what's particularly important for management to plan enough time. So 80% really got some data cleaning. It can be very messy and a lengthy process. So if you take this into your planning, you're probably, there is less disappointment and more success.
Thank you so much. Thank you, ladies and gentlemen, for being with us today. And yeah, stay tuned. Check our emails for more webinars in the future. So have a nice afternoon.